Now, I think you'd like to introduce the next section.
I think so. Thank you very much. When we thought about kind of how to compose this research section, I think a lot of people on the program committee, especially Beth and I, agreed that there is a big need in our community to work together to coordinate our efforts for using simulants. So we have a big issue with simulant availability in Europe. And when we thought about this, we thought we would invite somebody from the US who have like 20, 30 years more of experience, my personal opinion, on dealing with this and coordinating. So I hope we have Karen here. No,
Not
we
yet.
don't. Not yet. So let's hope Karen has I think it's called Lunar Surface Innovation Consortium meeting also in the US currently. So we first start with the European perspective. Kamini is here.
Yes.
Wonderful. Please invite Kamini, Manick, on stage, and I think everybody here needs to talk to her in the future when you use simulants.
This needs to be nearly horizontal for me. Hi everyone, good afternoon. Thank you so much to the organisers for inviting me to speak. It's been a great 2.5 days so far, and like everyone's been saying, it's nice to meet people face-to-face in 3D rather than on a flat computer screen. So my presentation is in 2 parts. The first part is on introducing the sample analog curation facility, and part 2 will be the results and outcomes from a scoping exercise that we've been doing on the European analog sample landscape. So first of all, just to introduce the team, I'm the curator and laboratory coordinator for the SACF. My research interest is in geotechnical characterization and adapting analytical techniques. I'm a geologist by background, but I've applied and practiced geology in the 3 sectors that you can see in the Venn diagram. So my background, skills, experience, knowledge all lie at that intersection. Xiaochen Zhang is my colleague. She's a young graduate trainee. I don't know if she's in the room somewhere, but she's at the conference, and I'm sure several of you have met her. And her research interest is in lunar resource utilization. And we've got Andy as well, who's our lab technician, and we're still a relatively young team, really formed back in September, and we have a new research fellow joining us over the summer. So onto the facility itself, what and where is it? It was originally created by the Natural History Museum in London by a team led by Professor Caroline Smith. In 2018, the facility was transferred to the European Space Agency, and the facility itself is on the Harwell campus near Oxford and is affiliated with ESA's EXAT site. And the facility itself is a geological repository and analytical lab. So that's to say we store rock and soil materials and we characterize them. So I have a few images here of what the facility looks like. We've actually reorganized it now, but we still have these sorts of general areas. So we've got an area for curation where we store the samples, prepare them, box them up. Sample analysis area. In this image, you can see a benchtop XRD in the middle there, and fume hood, vacuum oven. And a sample preparation area where we can crush rocks, mill powders, and sieve materials. So in terms of our vision, we want to achieve Center of Excellence status for all of our analog sample activities. So that includes curation, characterization, and our role as a networker on analog samples. So that in terms of connecting users with the samples that they need and building the network among simulant providers and other laboratories for characterization. Our mission statement is to be a European focal point for the curation and characterization of analog samples. And our aim is to provide expert support to users of analog samples and support them with understanding their requirements. Okay, I won't run through the objectives. There's a lot of them, and I make the same sort of points elsewhere in the presentation. In terms of our current status, we're still in a recommissioning phase post-COVID. This has involved setting up the new team, establishing our ways of working, and establishing protocols and procedures for the lab and curation, and also getting the instruments switched back on again. So having them serviced, recalibrated, so that we can get them operational. And the second half of this year will be an initial operations phase where we really try to refine the protocols, do a lot of things for the first time, and find ways to be more efficient, all in preparation for hitting steady state operations next year, where we aim to be working at a more consistent pace going forward. I thought it was worth just talking about terminology. I guess I get asked all the time about the difference between analogues and simulants. So just with the word analog, that's something that's comparable to or like something else. In the space context, we'll usually talk about analog samples or analog sites, so terrestrial things that are like extraterrestrial things. So an analog site on Earth is going to be similar to a site somewhere on Mars or the Moon or other planetary body. So in terms of analog samples, I'll focus on geological samples or naturally occurring samples. So I'll talk normally about analog rocks and analog soils, which are also known as simulants or regolith simulants. And if you're interested in this aspect, there's more that you can read in this reference here, JHU-APL 21. So from the the SACF perspective, who are the users? We have two categories we work with. So the primary users are our priority customer base. It's anyone working on ESA-led or ESA-linked activities, and we deliver support all year round. And our secondary users are anyone external to ESA and not working on an ESA-linked activity, and we do try to provide support on a best efforts basis, but it's on a restricted schedule. At the moment, demand is not so high that we need to distinguish so strictly between the two groups, but we may, over time, need to move to a call-out system, perhaps, for secondary users. And how do we support users? It's in these four main areas. Once we're operational, we'll be able to do characterization of analog sample properties, support users with requirements definition, and support them also with identifying and recommending analog samples, and also providing access and connecting users with analog sample providers. Just looking at time, so I'll just skip forward. So in the second part of this presentation, this is the scoping exercise. So the aim of this was to review the state of the art in Europe. So I started with individual consultations in 2021 with our primary users. This year in March, we ran a user survey, and then we held a simulant supplier workshop, which was co-organized by me and Beth and David. And that was in April, and I'll be doing a complete summary report of the entire exercise over the summer. So we had 36 respondents to the survey. These are the users, and we don't know what proportion of the entire European user base this represents. But the majority of the respondents were from ESA-led or ESA-linked activities, so the SACF's primary user base. We also had a look at the types of activities requiring stimulants from those surveyed, and the majority, as you can see on this heat map, the peaks were for lunar applications on spacecraft instruments and software development type activities, so engineering, technological development, and ISRU resource extraction. So I'll skip through these. The most compelling part of the user survey results was on the question where we asked people about their experience with using stimulants. We had 2 positive responses. And then in terms of challenges, additional requirements, there was a lot more there returned to us. And probably not a lot of surprises here. I'll just quickly highlight the topics that the SACF can more directly support users with, so on health and safety, understanding if a stimulant is fit for purpose, characterization and preparation, and accessing data and information. The items, the topics outlined in red here are where a wider network are required. So for the characterization, that's highlighted as well with the red box because we need a wider network of laboratories to provide all the capabilities for analyzing all properties that would be needed to be understood by the widest range of users. And then in terms of accessibility, availability, while we might be able to connect users with providers, there's still a job there for providers, producers to do to really enhance the availability of their product and advertise it more widely. In terms of research as well, supporting research and development of simulants. There's a lot being done at the moment, but in very separate places, and there's a lot less coordination. And also batch and quality control around the production side. So again, while we could characterize batches and give a comment, the actual batch control lies with the production side. So onto the workshop. I've got 3 seconds left, apparently, just 2 more minutes. But I'll jump to the outcomes, which I think are the more important aspects here. So we had a very fruitful supplier workshop. There were a lot of positive discussions. And the biggest outcome, and that everybody agreed on at the workshop, was to aim for a long-term strategic independence on simulant supply for Europe. So there are a few good reasons for this, the main one being that there's a lot of knowledge, know-how, and expertise within Europe for creating simulants and trying to produce them. It needs to be coordinated and supported and enhanced. But if we depend outside Europe for the supply, then that internal knowledge and understanding, et cetera, will diminish. So we want to keep that alive and keep advancing it. And also, at least we can control the factors associated with the production if they're closer to home. And also, we save on the time and costs and carbon footprint of importing, transporting samples. And then 2 other outcomes are more sort of actions for the ESA side. One is to create a network map of the suppliers, understand where the gaps are, and also look at group or community initiatives for continuing the conversation, especially among the workshop participants. I've got a list here of the remaining gaps that we've already identified. So the first point really relates to who are the key players, have we captured them all? We're aware that not everyone that's relevant were present at the workshop, so we want to keep building that network. A centralized European sales and distribution model. We can't sell simulants, so while we might be able to advise on what's available, we're not a one-stop shop for acquiring or procuring them. In terms of simulant products, a good range of high to low fidelity simulants for different applications and purposes. And something that's coming up increasingly is localized planetary simulants. Large-scale production and processing of simulants. And something that someone raised at the workshop was the need for the evidence for commercial viability, and that leads on to the final gap of needing to understand the market, the demand for simulants, who are the users, what is the true user base, how will the demand grow over the years. I just saw recently on the Regolith Twitter page that they had distributed 37 tons of simulant material last year and are aiming for 100 tons this year. So that's an interesting indication of that market. My final slide, moving forward, at the end of the workshop, we asked people to leave a comment on the key takeaway in the chat. And I've just popped them all here. You don't have to read them all. But the overwhelming message was simply that everyone was happy, and there was a strong desire to continue cooperating, collaborating, working together to really coordinate on the European simulant supply efforts. Thank you so much for listening.
Thank you so much for that really great summary. I think in the interest of time, we'll have to move on, but please find Kamini for questions in person or online as well.
Thank you, Kamini. It was a lovely talk, and I'm sorry we had to rush you. We do have Karen now. So Karen Stockstill-Cahill, can you hear us? Joining us from Johns Hopkins University. Karen, I hope you can hear us here.
Yes, I can hear you.
Lovely to hear you.
I apologize. For some reason, I thought my talk was at 7:04, and I must have had the conversion times wrong.
We're very happy to have you. Very happy to have you. Did you say 7:04? I don't know what time it is where you are right now. I can work it out as I sit down. But welcome. Good morning to you over there.
Thank you very much. Okay, great. You got my slides. I was wondering about that. Good morning, everybody. Thank you, everyone, for the opportunity. I appreciate the invitation. And I guess we can just go on to my next slide, please. Okay, so as we all know, regolith simulants are just an approximation of lunar regolith. There's a typo in the slide, which you can probably catch, that I am talking about the components that are generally used to produce these simulants by US providers.
Karen,
yes.
Sorry to interrupt you. Could you talk a tiny little bit slower, because the connection for the sound is not so clear. So if you could talk just a little bit slower, I think we might be able to understand a bit. Thank you so much.
Okay, absolutely, sure. Sorry about that. So lunar regolith simulants are composed of anorthosite. The US providers tend to use a couple of different sources. One is the White Mountain anorthosite, or green spar from Greenland. That has an AN content of 83. Or they use the Shawmere anorthosite complex from Ontario, Canada, which has an AN content of 78. And on the right there, I'm showing a plot of the AN number going from 100 on the left to 70 on the right, of various lunar regolith simulants, or lunar regolith samples. And the Mare are on the bottom. The anorthosite is on the top, and you can see that the terrestrial range shown in the little turquoise bar there kind of overlaps with the lunar regolith, but it is a bit too high in sodium content, and that comes up later. In terms of basalt, the providers are generally using the San Francisco volcanic field. In Arizona, they use a basaltic cinder to replicate the glassy components that are present in lunar regolith. And then they'll oftentimes add some ilmenite to increase the titanium content. But in general, the simulants are missing agglutinates. There are some providers that can make pseudoagglutinates, and you can add that into their simulant products. And they're missing nanophase iron metal and amorphous mineral rims. Could I have the next slide, please? Okay, so there are approximately 4 Highland simulants that we looked at for our 2021 assessment. On the top there is the Regolith simulant. That's the Highland simulant. In the middle on the right is the off-planet research. I will note that is a far side simulant based on remote sensing data. And on the bottom is the Colorado School of Mines simulant. And on the left, I kind of enlarged it because they're kind of a pretty rock, but it's the pseudoagglutinate produced by Outward Technology. And that product is generally agnostic to the source. So you could use any of the provider simulants and create agglutinates from that. Next slide, please. And these are the Mare simulants that we are looking at. Again, it's Regolith on the top, off-planet research in the middle, and Colorado School of Mines on the bottom, with the Mare agglutinates simulant shown on the left there. Okay, next slide. When we've evaluated them, we kind of look at composition and particle size and shape. So I'm going to start talking composition. We looked at the bulk chemistry using XRF on a bulk sample. We repeated analyses on 5 splits of bulk material, and we were pushing the detection limit for magnesium. So sometimes it was a little below the detection limit. And we also couldn't measure sodium. Those are both light elements that we couldn't pick up in this particular method. And we also did mineralogy using XRD. We used a reference intensity ratio method, which gives us semi-quantitative abundances for when there are multiple phases present. And I just note that it doesn't pick up on non-crystalline materials, so those glassy basaltic cinders can be a problem. Next slide, please. And this is the bulk chemistry we got for the Highlands simulants, which are shown in the color bars. And I'm comparing them to an Apollo 16 Highland Regolith shown by the black bars. You can see that they have a higher sodium content. We used SEM data of the 125 to 250 micron split to get that data. They also have a higher titanium content that'll make more sense when we talk about the Mare simulants. And they have a lower magnesium content. Next slide, please. So there's a lot of data on this page, but it's looking at mineralogy. The Apollo 16 is shown there in the upper left. It's a pie chart. Plagia's in blue, pyroxenes and olivines are in green, and opaques are in yellow. And I have that same XRD data for the simulants shown next to their SEM, beautiful SEM images. And I brought in the SEM because, as you can see, for off-planet research in Colorado School of Mines, it doesn't show any mafic components marked. There were 100% plagioclase. But clearly the SEM data shows the plagioclase in blue and the mafic materials in orange and green. And you can definitely see that we don't have just 100% plagioclase. So we're seeing a pretty good match to the bulk mineralogy. Next slide, please. And these are the Mare simulants. Again, the simulants are in color bars. We have a low titanium Apollo 15 Regolith in gray bars and high titanium Apollo 17 in black bars. And you can see that the providers are aiming for sort of an intermediate titanium content. Again, we have too much sodium and low magnesium for these. Next slide, please. And here again is the mineralogy. XRD does not do a very good job of matching the two regolith simulants or regolith samples that you see there on the left. So again, we went back and looked at the SEM data, and we do see a pretty good match. Next slide, please. And finally, we looked at particle size and shape. We used the CAM sizer instrument shown there on the bottom left. We had particle size bins of 3 microns, so they go from 0 to 3, 3 to 6, etc. And we did it for 3 aliquots of about 100 milligrams each. And you just pour that material into that little cone shape thing at the top, and it blows the material across the field of view, and there are high-speed cameras that capture the information for us. It also produces, in addition to particle size, it produces various shape parameters, including aspect ratio that I showed there on the right. So we're just comparing that B axis divided by the A axis. So a perfect sphere would be 1. This one is obviously not 1. It's probably more like 50 or 0.5. Next slide, please. And this is the results of the aspect ratio. On the left, I have the Highland simulants. On the right, I have the Mare simulants. I am comparing them to the Apollo samples, which are shown in those gray, large gray bars. So one thing you'll notice is that the simulants are still a little bit more round than the aspect ratio that we get for Apollo samples. The other thing you'll notice is that the regolith, lunar regolith actually shows a wider range of aspect ratios. Next slide, please. And then this is the particle size distribution plots for each of the 3 exolith off-planet in Colorado School of Mines. On these plots, on the x-axis, we're going from large grain size to small, and the y-axis is % finer. And so you can see that, oh, and we also plotted the Apollo sample, average Apollo regolith in black with gray being standard deviation. And you can see that we have much steeper plots and larger abundance of large particles. Next slide, please. So these are just the conclusions. What's really important to know is that your application is going to determine what you need in terms of fidelity. You might need high compositional fidelity if you're trying to melt, but if you're doing durability studies, you might need something that's better for particle shape and size. I will note that most needs for experiments can be met by the existing simulants, and where they are fall short, you can actually add your own components to increase the fidelity. And I think ultimately for advanced studies, we may need to study these with simulants that have pseudoagglutinants in them, and potentially even just study it with lunar soils, which of course on Earth are limited, but at the lunar surface are more abundant. So next slide, please. So I'm just going to leave you with this. This is the Lunar Assessment. If you would like to access it, you can, if you're an LSIC member, you can access it on Confluence, which is that first URL, or you can go to the public webpage. And I'd be happy to take any questions.
Thank you very much indeed, Karen. Do we have a question? Yes, we do.
Yeah, thank you so much, Karen. That was really interesting. I'd be interested to know what you think is currently the biggest gap or missing material in the simulant market, and what would be the most useful thing to add going forward for research?
I guess it sort of depends on the experiment itself, but I think in terms of compositional fidelity, the biggest gap is that calcium number. So some people are working to sort of add synthetic components that might provide a better compositional match. But that higher sodium content is going to have issues for studies where they're melting materials, because the higher sodium content changes the melting temperature a little bit, but it changes the viscosity quite a bit. So you're going to have the material is going to melt and behave differently with the higher sodium content.
Do we have any other questions from the audience even? I think everybody's ready for lunch over here, Karen. It's your breakfast time.
That's okay.
Do you have a question, Dave?
Yes, so just a comment, I think. Thank you, Karen, very much. And the work I think Karen presented is like the outcome of, I don't know, 20 to 30 years of coordination from NASA with the simulant working groups. And I invite everybody who's working with simulants to look at these reports, because they kind of try to make assessments every year. Is that right, Karen? So
yes, absolutely. We're gearing up for the 2022 assessment now.
So we also, like in our community, in the scientific world, like we need to ask ourselves, is the base of our scientific work, is some kind of material one group made up and nobody else can assess, like can get it? Is this science? So I think really everybody who's using simulants, everybody who's thinking of making their own simulants, talk to the SACF, and we need to really coordinate on this. Otherwise, we cannot take ourselves seriously as scientists.
Have you anything to add to that statement, Karen?
I think he's absolutely right that we need to consider the fidelity of the simulants and talk to experts. So we do, on the Lunar Surface Working Group page on Confluence, we do have a list of both NASA and APL people that are working on these on a daily basis, and they can provide some guidance. But overall, I think the simulant providers are doing a great job of improving the simulants. We've seen improvements just based in the last 2 years after starting these assessments officially. So I'm very encouraged that we're moving in the right direction.
Karen, thank you so much for your time and for joining us this morning. We're very glad that you did make it in the end. So round of applause for Karen once more. And now for everybody here, it's lunchtime. We will return here in the seats at 1:30, so 45 minutes for lunch. Back here at 1:30. Thank you so much.